Good morning, everyone. I am Jeff Blankenburg, and as we do most Thursdays, welcome to Alexa and Friends. Today, I have the good fortune of joining me, Daniel Marcu from the Alexa AI organization. Thank you for being here, Daniel.
Oh, thank you for having me.
Certainly. So, as most of our guests, most of the people that tune in and watch this show regularly know, I like to start our episodes with kind of some silly, peculiar questions. I think they help people understand who you are a little bit as a person, and as I tell everybody, you've not been prepared for these questions, so you don't really have answers prepared, and that's okay. I think that's part of the fun of this, but it's also an opportunity for people to get to know you, the person, not just you, the scientist, right?
All right.
All right. So the first question that I'd like to ask you is, if you could have one superpower. Just one. Like, you can't be Superman. That's a lot of superpowers. But if you could just have one superpower, which one would you pick?
I wouldn't choose one.
You wouldn't. Right?
And the reason I wouldn't choose one is, I mean, just think about yourself or myself. Let's say at some point, maybe one superpower was that I would like to know how to drive a car. But then once I learned how to drive a car, it was no longer such a big deal. So
okay.
I think, at least for me, the more interesting part would be, I would be interested in working on developing a superpower. But I don't think I would just want to have a superpower handed over to me.
Oh, wow. That's maybe it's too much power. What? Okay, so let's flip that around then. So if you don't want to just have one assigned to you, what if it was like most of the things in life, right? If you spend 2,000-3,000 hours practicing something, then you become like an expert at it, right? You become someone that's very proficient at it. What if you had to earn it that way, and like there was something you could just really refine your abilities by practicing and really focusing on it? Is there something then that might appeal to you?
Well, I think there are lots of things that appeal to me on that front. Maybe I would like to be a better climber, mountain climber, to really get to the top of Mount Everest one day.
Wow.
But not just for the sake of it, not the top of Mount Everest, but let's say to get to places that are less accessible, so that I can see more.
Wow. I would like that too. That would be excellent.
That would be on the list. Maybe playing guitar better than I play, that sort of stuff.
I play guitar very poorly, and I don't think any amount of practice is going to change that, but that's okay. All right, so speaking of guitar, this is a good lead-in. Let's pretend for a moment that you have a band. You're in a musical band, maybe a rock band.
Sounds good.
Yeah, it sounds
Actually,
sounds great, right?
No, when I was doing my PhD, I thought at some point that the ideal lifestyle for me would be to do research during the day and play in a rock band in the evening.
Wow. All right, we hit a nerve here. That's good.
You're on the good track.
Excellent. Okay, so you've got this band. You're the leader of the band, and you guys are sitting around deciding. You've got all these songs, and you want to decide what the name of your first album is going to be. What would you name your first album?
First album. Let me walk from maybe one song that I like a lot, or let's say a rock song that gets me going every single time I hear it.
Okay.
So every single time, for example, I hear Bon Jovi, "It's My Life." Doesn't matter whether I'm happy or whether I'm completely tired. It just pumps me back.
That is a good one.
To life.
That'll get the heart pumping. That's a good one.
I love the song. I love the lyrics. I love the video that comes with it. So I think it's very inspirational to me. And I think the reason it's inspirational, it has lots of zest for life. So if I was to choose an album, the title probably would be something along those lines. So I like to do things with zest and I like to completely immerse myself in what I'm doing. So maybe immersions or journeys, because I do think that it's fun to kind of change once in a while everything that you do and start over and immerse yourself in something else. So maybe journeys or immersions or something along those lines.
All right, cool. That's a good answer. I like that. It's a good reflection of who you are. Um, all right, I like that. Okay, so last question. This is always the last question, and I really I'm always curious in the why of this answer more than I am your actual answer. But the question is, would you rather, if you were forced to choose, would you rather have to fight one horse-sized duck or 100 duck-sized horses?
One horse-sized duck versus 100. Oh, I would rather fight the one.
The one big one. So what's your reasoning for that? How did you decide?
I think it's much easier. You kind of learn much easier what the strength and weaknesses of that horse-sized duck is, and devise strategies easier for fighting the duck. I think it's definitely a much easier task putting up with 100 ducks.
Yeah, I think 100 tiny horses would be pretty challenging. I mean, imagine being surrounded by 100 ducks. That would be scary.
100 tiny horses would be a little bit overwhelming,
so.
But with one size or one horse size duck, I would be comfortable.
All right. So I like that. I feel the same way. I often imagine what it would be like. I feel like it would be very majestic to ride a horse-sized duck. I feel like I could imagine myself in like Revolutionary War garb, like with a sword charging into battle, riding a giant duck. I think that would be pretty cool.
The closer that comes to that is riding an ostrich.
Yeah.
Right.
Yeah. But
have you tried that?
But I'm hoping just by scaling up a duck, it can still fly. Because ostriches obviously are land-bound, but man, if a duck that size could also fly, whew, we got something. That's that would be a lot of fun. Okay, so let's get into some seriousness. One of the things that I really like to share with people when we have guests on this show is to help them understand kind of who you are, what your titling, your role is here at Amazon on the Alexa team, and then a quick kind of journey through how you got here. I know for me, I didn't go to school to do things with voice or natural language understanding or even AI. I actually have a degree in psychology, but I was really good at software development, and I found my path that way instead through my career. And I find that that's true for a lot of people. There are a lot of people involved in voice that they don't have a naturally obvious educational path or even early career that got them here. And I think yours is probably a bit more traditional, maybe what we would have expected. But I'd love for you to share first kind of what your role is at Amazon and then how you got here.
Yeah, so I'm a director in the Alexa AI organization, and the way I think about my job is to make Alexa smarter as it comes to Alexa understanding and dealing with the information needs of customers. And how did I get here? So I was born in Romania, and I did my undergraduate studies there. And at some point, I think I was in the third or fourth year of my undergrad. I was in the library just browsing through journals that were at that time maybe 15, 20 years old, because the internet was not invented yet.
Sure.
And the library in a communist state did not have access to the latest journals. So these were journals from the 70s. And as I was browsing through journals just to see what were considered interesting topics in the 70s, I came across an article that was written by Bill Woods in the Communication of ACM. And that article talked about how you can build a natural language interface to a database. So the idea was that you ask a question in natural language, and some magic happens and you get back the answer from the database. And when I came across that article, I was just blown away just by the idea that you can build computer systems that handle natural language that like people. So at the time I like mathematics, I like computers. So then I said to myself, that's it. That's what I'm going to do with my life. So so then I went from that to actually building a translation system for my graduation project. So I built an English to Romanian translation system, and then I went to University of Toronto in Canada, and I did a master's and a PhD there, and then in natural language. And then I took a job at the Information Sciences Institute, the University of Southern California, and I became a researcher there and continued to do research in quite a few areas in the natural language processing field. I also, at some point, started a company that Language Weaver. That was the first company that commercialized statistical machine translation software. That was a time when statistical approaches to natural language were, let's say, revolutionizing the world. No longer the case. Now it's neural systems. And then kind of found myself splitting time between the university, the company, grew that company, got it, it eventually got acquired, spent the time with, some time with the acquirer, went back to the university, and towards the end of 2016, came to Amazon.
Oh, very good. So you and I got here about the same time. I joined, I just hit my 4-year anniversary 2 weeks ago. So you must have been just about the same time.
Yeah, so I started in December. So in December I'll be
very good.
4 years.
Very good.
Amazon.
Very good. Well, I'm glad you're here. Okay, so you ended up going from Romania to Toronto. How was I mean, it sounds to me like you did a lot of very interesting things. Some interesting work, certainly for your PhD, certainly as part of that company that you started. Do any of those things still live on? Is there any like work that you've done early in your career that you can still say like, oh yeah, some of my work still sits over there, or this product is using something that I put together?
I think some of the ideas have been let's say adopted or transitioned, but in different forms, even in products that are used today or in techniques that are used today. But the field of natural language has underwent maybe 2 revolutions since I started. So first it went from using knowledge-based approaches to natural language to using statistical techniques, then moved from statistical techniques to neural techniques. So in that process, what typically when you go through those science revolutions, as Kuhn calls them, for example, what survives is not so much the methods, but some of the core ideas behind those methods. So it is typically at that level that things have survived, not the particular approaches.
Got it. Okay. So what was if you had to identify something that was kind of the main draw for coming to Alexa, right? I mean, you said you'd been jumping between your own company and certainly academia. What was the draw to be able to come here and to be able to work on a project like this? Is there anything that stood out to you as like, oh, that's something that I really want to address?
I think for me is what really attracted me to Alexa and to Amazon in general is the opportunity to do research that has such a broad customer impact. In the past, I did quite a bit of research in an academic setting and figured out how to do that well, I think. And then also I figured out at some point, I mentioned at some point that I kind of liked journeys, right? And I had at some point, part of my career was very academically focused, and I was focusing then on just how to write as many good papers and publish as many good papers as I could every single year and do research in as many research areas as possible. And that was super, super exciting. But at some point, I thought that was no longer that exciting. What became more exciting was to figure out how to build a company from scratch with friends and colleagues and partners, business partners, and how to do science in support of that, right? And because and it had to be some company that also had a strong science component in it. Right. If it didn't have a science facet, that would have not been exciting enough. But to figure out how to do science in the context of a startup and then also in the context of, let's say, medium-sized company was super interesting. But I've never had the opportunity to do science in a company that has the footprint and the customer base that Amazon has. And I thought that I can learn a few things in the process if I was to work for Amazon. So that's the reason I ended up at Amazon. And I think the second reason is if you look historically at the way different fields have evolved, at some point when certain fields, scientific fields, become a little bit more mature, I think more interesting research is happening in the industry. So initially, lots of the research, let's say in databases, for example, we talked about that in the beginning. Initially, lots of the interesting work in databases have happened in the academia. But at some point, I think that most of the interesting work in databases became driven by the commercial sector when that became something that hundreds of millions or billions of people could put to good use. Right. And I think the natural language field has gone through a similar transformation. So definitely when I started my PhD in natural language processing, it was purely a passion-driven enterprise. I just loved natural language, and I thought that getting computers to understand and deal with language in a way that people do would be the most fun thing to spend my time on. But nobody cared about it in the industry at that time.
Right.
Now, that's no longer the case. I think today there is more research, good research, and the field of natural language processing is advanced much more in the context of in the commercial sector than in academia.
Got it. Oh, that's very interesting. Do you think that there was a tipping point that happened? I know that probably eight or so years ago, there was a moment where all of a sudden we had kind of crested this recognition ability of natural language understanding and a number of other things that made it really possible for things like Alexa to happen, right? I mean, we've had the ability with computers to be able to recognize speech for decades, but it was always a very limited vocabulary. I know that there were some folks that I talked with that they were building systems in the 80s that would let people like vote for the class president, but it could only really recognize two terms, right? That was the extent of it. You couldn't say anything like we do with Alexa today. Was there a moment that you can identify that kind of like highlights why there's so much research in voice and why it's become so important?
I think it's been accumulation of many years of investments, and I have to credit the U.S. government for being behind the investment in voice and in natural language technologies for so many years, for decades, at times when everyone else thought that would be a lost cause.
Right.
And I think that funding that the U.S. government has put into many academic institutions at that time to just continuously raise the bar and continuously transition, let's say, from speech systems, let's say, recognizing maybe a handful of words to then maybe recognizing continuous speech, but for very small vocabularies, and eventually getting to where they are today. And the same thing for machine translation, the same thing for information retrieval systems. So I think it took essentially that investment started in the 50s. In the 60s, kind of took a downturn. It almost came to a halt. In the 70s, it was rehabilitated, but it took from the 70s to, let's say, early 2010 or so to get to the point where we or Amazon, let's say, felt comfortable to say, well, I think the time is right. Maybe we can bridge the gap between where the technology was at the time when Alexa was a project on paper to the point where it became a reality and it launched as a product. But I think it's the outcome of not just one, let's say, innovation, but it's more the result of 40 years of investment in the natural language processing area and speech recognition.
That's good to know. I don't think a lot of people realize. I mean, Alexa's obviously been around for 5 or 6 years now, and I don't think a lot of people realize just how long the tail of the research that led to the capabilities that we have today has really taken, right? It's not as if someone had an idea in 2014 and they're like, this is something we should try. No one's ever done this before. It's obviously been something that's been going on for a very long time, longer than my lifetime, actually.
Yeah,
and it's great to see
and
that.
That's why I think it's super interesting to do research at the cutting edge of science, because I think when you do that, and in a commercial setting, because I think when you do that, it's not only a question about what paper can I publish next, but it's also a continuous, let's say, a search for figuring out what customer capabilities are possible to develop given the current state of technology. And then there's quite a bit of innovation that happens not only from the perspective of advancing the state of the art in some particular technique, but it's also, I think, lots of innovation that has to happen in terms of bridging the gap between some existing customer need or some need that customers don't even have an idea yet that they have that need, like it was the case for Alexa, right? And then doing the science that is needed in order to get to delivering on that customer.
Very cool. Okay, so you we talked about Toronto, but you also mentioned that you were at USC for a long while actually. And I'd love to know, this is one of those things that I don't have an opportunity to really reflect back on, because I did all of my research and education in psychology, right? So I really spent a lot of time thinking about how humans think, which actually applies very well to what I do today. But when I was back there and I was thinking about the research that I was doing in psychology, almost none of that applies. Like, none of the lessons that I really gained from that apply greatly to what I do today, because I've pursued this path of being a software developer my whole career. But I would imagine someone that has been in academia for a good portion of their career, and then you come here, there's got to be some experiences or some learnings or something that you've gained as a part of that world, as part of that research world, that you find yourself able to apply here at Amazon. Is there any interesting stories or learnings that you have from that?
For sure, and I'm very grateful for tons of things that I learned while I was at USC and at ISI in particular, the Information Sciences Institute. Let me say that when I graduated with a PhD from University of Toronto, I think I had a very limited understanding of how the world operates. And I just imagined that if that my job is simply to write science papers and advance the state of the art, and I did not have any, let's say, the connection between that and where is the funding coming from?
Right.
Who's paying for all this? That was a complete mystery. It kind of did not enter my, it was not part of my thinking, which I think is actually what it should be.
Yeah, that's a good problem to have. I have many friends that in academia that most of their own personal income is tied to grants and a bunch of other stuff that they really have to work out. So not worrying about the money and just being able to do the research sounds great.
Yeah, so I think that's what students should do, right? They should not have any worries about the students should, when you do a PhD, you should have the freedom to explore whatever area that you want and to go in whatever direction your passion takes you, which is definitely what I did for my own PhD. But going back to lessons that I learned from USC, I think the first thing that I learned was to be entrepreneurial, to be self-sufficient. So when I got there, I was kind of shocked to learn that, geez, I need to figure out a way to pay my salary. So Information Sciences Institute was a soft money institution, so you had to generate research grants in order to pay the salary.
Sure.
And obviously, when I joined, somebody was doing that for me, and that made me profoundly uncomfortable. I did not feel comfortable to depend on the ability of somebody else to write grant proposals and to fund my research, because I felt that there is quite a bit of a disconnect there. So I was thinking I can do the best research, but if that person misrepresents my research or doesn't do a good job as a fundraiser, then what? So I think that the first thing that I wanted to learn was how to become self-sufficient, which is how to generate enough ideas and deliver enough value to justify my own salary and the salary of the people that work
That's a
for
good
me.
lesson.
So I think, and I continue to be, I think, entrepreneurial and try to stay self-sufficient and always function with that in mind, thinking that nothing comes for free in some sense, that you need to make sure that you create sufficient value with whatever you do. I think the second important lesson was that um, or the other super important thing that I learned was that it's a good idea to have a very high bar on science but in general on the people that you work with. Uh, I learned that you do not need 100 people, you do not need 1,000 people to to become the world leader in a particular field. So I think with a group of 5, 10 people, you can really take an area like speech recognition or machine translation or you name it. And if those 10 people are the right sort of people, that group can become the world leader in that particular field. And yes, it's way more complicated to go from that to, let's say, building products and all that. But I learned that surrounding myself with awesome people that know more than me and learning from them and just having a high bar on that is probably one of the biggest, let's say, drivers of success than anything else. So that's definitely something that I also took to Amazon when I came
That's
here.
good. Yeah,
And
I think you see that here. We often refer to them as two pizza teams, right? The idea
exactly.
that, and that's something that a lot of people that may be watching may have not heard. That's an Amazon term, I think. But the idea of a two pizza team is that if you're working on a problem, you shouldn't have more people working on the problem than two pizzas can feed, right? And I think that's a really good philosophy because you really just want to get the key stakeholders, the key players, and adding more bodies doesn't solve more problems.
Absolutely. And I think maybe also aligned to that, I learned that focus matters. So initially, I was very, let's say, broad in my approaches, and I was trying to solve problems in as many places as possible and advance the state of the art in some sense indiscriminately or opportunistically, if you want. So I would see something that I thought I could do better, and I was doing that, and then here and there and there, and little by little I learned that it's better to do one thing super well than doing 10 things just
Mediocre.
well
Yeah.
enough. And later, a friend of mine said, or summarized that very nicely. He said, well, this is like physics. It's pounds per square inch, right? So the smaller the surface area that you focus on, if you apply the same force, it's the likely the impact, the higher the
Yeah.
impact. So I think that's a good summary. So focus, I think, is also super important, which is again something that is equally important now in the context of
Oh,
Amazon.
for sure. Okay, so there is an event, KDD 2020, going on this week. And I know we wanted to make sure that we mentioned that that's going on. But I think it also gives us a good opportunity to kind of talk about knowledge discovery and information retrieval and things along those lines. So those are the things that your team focuses on. Can you tell us more about what your team is doing and what you're working on?
Sure. So my team is focusing on enabling conversation-centric question answering capabilities on any Alexa devices and supported languages for customers that have some information needs. And the focus of my team is on unstructured data. So customer find will find that Alexa responds to their questions in different ways. And my team at the moment is helping Alexa customers in three very concrete ways. So, for example, Alexa can answer individual, something that we call factoid questions using unstructured data. So like quoting from some narrative source. So if you ask a question like, what is an ostrich? You would get a cohesive response that is undrawn from some unstructured data that is available on the public web. So putting into place all the techniques that enable those responses to be generated and building the service and doing the science and continuously improving that service is part of what my team is doing.
Okay.
A second capability is, in some contexts, maybe you're looking for, if you have a more open-ended question, like what's going on with the election, for example, maybe just a short answer will not do it.
Sure.
Right? So in that instance, what we do is we look at news sources such as Reuters, for example, and we figure out how to provide an answer, a summary that is a little bit longer. It's just not one. It's not just one short sentence, but it's a little bit longer, right? Because there's quite a bit going on. And the third thing that we've been working on is trying to transition Alexa from just answering the question to engaging or helping customers engage in longer dialogues. So if you ask the question like, what's the population of Louisiana, for example, you may get the answer, but in the context of today's events, maybe you wouldn't mind if Alexa would come back to you and say, hey, would you like to hear the latest news of Hurricane Laura or the impact of Hurricane Laura on Louisiana, right? Because that's something timely, and some customers may like to get that information.
Yeah, it expresses that. Like, I've already expressed my interest in Louisiana, just by asking for the population. So I clearly have an interest in that region. I think that makes a lot of sense.
So those are the three customer experiences or services that my team has developed in the context of Alexa, and of course they're never a done deal, right? So how you continue to improve those experiences and how you create, how you can make them better and better for the customers, that's a continuous focus in the team.
All right, so I have a follow-up question to that, and this is just something that's interesting to me because, again, as a developer, somebody that's built lots of things for Alexa, I find that I'm always clamoring for structured data, right? I want a data source that just has the information that I need in an easy, queryable fashion, and I wish that I had that thing. So it seems to me, because there is such a broad range of data, and so much of it is unstructured, right? There's so little that we can actually say, like, oh, I have a finite set of data, and here it is, and you can use it in this organized fashion. Do you know, not inside Amazon, but is there is there even the idea that someone's trying to build like a universal database to try to solve the structured data problem? Because
I
that seems like
think
such an overwhelmingly large problem.
I think there are quite a few initiatives focused on that. Some inside Alexa, some inside other large
Wow.
companies, some even public efforts. And I think definitely there is those techniques or developing those large knowledge bases or knowledge graphs, how they are used, uh, constitute one of the important ways in which Alexa tries to satisfy customer needs, right? So especially if you think of questions that are asked again and again, right, to the what is typically called, let's say, the head questions or the questions that are the top of the distribution. Um, uh, it makes all the sense in the world to figure out how to develop the knowledge resources and to distill the knowledge in the world that is essential for people's needs and deliver that to them in slightly, let's say, less evolved fashion,
Gotcha.
right? By visiting that knowledge graph and finding the appropriate information in that knowledge graph. The unstructured data that my team is focusing on is like, okay, kind of like the long tail of questions for
Sure.
everything
Yeah.
else, right? So I think there is always going to be a long tail of questions that customer would want to ask and to have answers for. And it seems to me that creating the capabilities that can tap on unstructured data is the correct approach there to go.
All right. Okay. So as Alexa kind of came on, and we really think more about this human machine interface, right? Because a lot of people will think of a human machine interface as like me typing into a laptop, but it's really not. When we talk about human machine interactions, we're really talking about a way for me to communicate in a natural way and for the computer or the machine to be able to understand me. And it really is unlock things, right? I control appliances all over my house. I control light switches and my garage door and all that kind of stuff. And I just talk into the air, and this all stuff happens like magic. Um, from what you guys are focused on from your perspective, what makes interacting with an intelligent device, what makes that information retrieval that you're working on, what makes that different from like me typing things into my computer?
Let me preamble that by saying that I think that Alexa already does lots of amazing things. It plays music, it wakes you up, as you pointed out, it tells you the news. You can listen to the news on
Right.
Alexa, and tons of stuff that in many instances, even myself, when I joined Alexa, I didn't know that Alexa was so smart and it knows how to do so many things. Having said that, I think that Alexa, and not only Alexa, all digital assistants, I don't think they're that smart yet.
Sure.
And I think that they are still far from being able to enable people interact with information in the same way people interact with each other, and also in the same way people interact with information even on a desktop computer. Okay,
Sure.
so let me maybe break this down into a few dimensions along which it's a little bit different, right? So when you deal with voice, first of all, you kind of need to figure out there are some errors that come from the voice, right? Which are typically maybe fewer than the typing errors that you can, and they're easier to catch typing errors because you see already the words in print and you can apply tons of algorithms that work a little bit
Yeah.
easier
You have more
on
context, for
type.
sure.
Yeah. Then understanding it's understanding errors, right? So also the way, if you think, especially if you think of conversations that you have with a machine in natural language, or multi-turn interactions, there's lots more going on there compared to what people do when they just issue a sequence of queries in their desktop, right? So you're much more conversational. You use lots of ellipses, anaphoras, what linguists call anaphoras. So the machine kind of needs to figure all that out, right?
Yeah.
Then the you have a fairly narrow communication channel, right? And you need to figure out how to use that very wisely. So should I produce a short answer? Should I give a long answer? Should I provide a summary? If I didn't understand the question, should I try to clarify the question? Should I recommend a follow-up topic? So all those are things that you kind of need to solve, right? And the last one, just think a little bit how many things you can do, let's say, when you interact with information on a desktop today, right? You research, you bookmark, you save pages that you go to them later, you cut and paste, you compare alternatives. Sometimes you spend weeks trying to figure out where you go, for example, for your what to do for your next
Oh,
vacation,
I
right?
definitely do that. Yeah,
And
for sure.
and then if you think of digital assistants today, there are no equivalent, let's say, behaviors on digital assistants today. And I'm not saying that they need to be, by that, I'm not suggesting that eventually these capabilities are going to be worse. Right? Maybe to pick up an analogy, think of how, let's say, our listening habits have evolved, right? So at some point we had records, and then a big innovation was we could take some of the records with us on the road with the Walkmans, right? With the cassette, the portable cassette players,
Yep.
right? And at some point, the next big innovation was that it was okay not to carry just 10 tapes in your bag. You could carry all the music collection that you have on an iPod, right? And the interface there was very different, and the manner in which you interacted with that music was very, very different. And then you could actually ask Alexa to play a
Right.
song, right? So it's not that it got worse, it actually got better.
Yeah. Yeah. Yeah.
It removed
Uh,
the friction. You removed all the friction, and eventually, by having the voice interface to playing music, our ability to kind of satisfy that need just got better and better over time. So from that perspective, I'm saying that I think digital assistants are still pretty dumb. So we're still in the Middle Ages as it comes
for
to
sure.
development, or day one, as Amazon
Right. It
calls
is
it,
still
right? So
very
we
much
still
day
have.
one.
So
Yeah. No. That's an excellent analogy. I think as we look at the progression of these things, I think that we'll find that more and more. Going back to your vacation analogy, even. I mean, I think about this. My family and I, pre-COVID, we had booked an entire trip. It was 8 days in Hawaii, and we were really looking forward to this. This is the last. I've been to all 49 states. Hawaii is the last one, and I was really looking forward to like checking that off. I've been to all 50 U.S. states. It would be a great trip. And then with COVID hitting, obviously we had no vacation, and we looked around and we're like, where could we go? And so we'd been to the beaches of North Carolina before, and a lot of it, the area there is called the Outer Banks. And so we went, we found a house, a big house, right on the beach, and we decided instead of quarantining in our house at home, we'll just quarantine on the beach. What's the difference, right? We'll just drive down there and do that instead. But it took a lot of research and time and finding the right houses and the right locations, and figuring out what restaurants would be available and what activities can happen. And I yearned for an opportunity to just, ask my assistant. I'm going to stop saying the name because I know people in the chat have said we've set their devices off a few times. But being able to get that kind of information. I mean, think about even with a search engine today. You go in and you type something in and you get a list of results, and the first 10 aren't at all what you wanted. You need to really dig down and find the one thing that you're really looking for. And it's not that it's just hard with voice, it's just hard to be able to funnel down to the data that you're really looking for. So it's exciting to know that we're working on these kinds of things, and that's ultimately something we should see, like music, should get a whole lot better, should get a whole lot more intelligent as we move forward. So that's exciting. Thank you.
it's a long haul.
Yeah. It is a long haul. Like you said, you've been working on this for a very long time. So you're also involved in machine translation efforts, though, right? Can you explain some of the ways that customers are actually benefiting from machine translation and maybe some of the science behind it? I'd love to get a little a little deep into what that means, how it's beneficial. Maybe a lot of the viewers may not even know what that is or how it works. So anything you can share, that would be great.
Sure. So I've been involved with the machine translation field for 22 years now, I think. So um, that was actually what the company that I co-founded, Language Weaver, did. So it was the first company that brought to market a data-driven statistical translation approach to machine translation that at that time was revolutionary in the sense that it transitioned from building machine translation systems by locking into a room 10 linguists for several years and asking them to write rules that explain how to translate this word or that word, to just looking over their shoulders and saying, okay, here are some translated data that these human translators have produced. Now, can we have a machine that learns automatically how to mimic that behavior, how to take, by looking at examples of work done by professional translators, can we build a machine that can, given a new sentence that has not been seen before, can we mimic that and produce a new translation for that sentence that is good enough? And the field has gone from, as I said, people initially writing all those rules automatically to then the statistical approach was statistical methods for doing that, and now the neural techniques are just following the same data-driven approach. It's just that the techniques that we use to learn from these examples are based on neural models. So that's kind of the evolution of the field in a nutshell, very high level. Now, you asked about customer benefits. I think machine translation has improved massively in the last 22 years, and the places where Amazon, for example, I think it would be difficult, if not impossible, to function without machine translation.
Yeah.
So in the area of what is called content localization. So you think of Amazon being available not only in English US or other English speaking languages, being available in all the other countries around the world, all the information that needs to be translated to enable those customers to access data in their own languages. I think it would be impossible to translate the vast amounts of information behind the entire Amazon organization using professional translators.
Right.
There are just not enough professional translators on the
No.
planet to do that,
No.
right? I think other areas where machine translation now play a significant role, customer engagement in call centers, customer chats. So in the past, if you lived in Germany or in Japan, and if you wanted to have a conversation with a customer support agent, that customer agent had to speak Japanese, for example, or had to speak German. Yeah. And there are just fewer people who speak Japanese and fewer people who speak German than people who speak, for example, English. So today, lots of those customer support or customer engagement lots of the behaviors are happening via machine translation. E-discovery, I think it's a big field. Going from vast amounts of data available in multiple languages to drawing insights, processing all that data. Alexa, to a certain extent, right? So making Alexa available in all the languages, also machine translation plays an important role in accelerating the way in which we deploy Alexa across many languages. And so I think those are just a handful of the places where machine translation has fundamentally changed the world. And now you also asked about the science, I think.
Yeah, if you could share.
The science, I think, when you look at the current, where the field is today, improving accuracy is something that has been going on for the last 50 years in machine translation, and we're not done yet there. So the field still continues to work on improving the accuracy, and that is particularly important for what is called low density languages, languages that do not have that much data. So if you look at languages like Spanish and French, there are tens of thousands of professional translators available in those languages, billions and billions of words that those languages have in parallel data, meaning translated data produced by professional translators. So so let's say building good translation systems for Spanish and English and French that are high density languages, just because data is there, is much easier than doing that for languages that have very little parallel data, very few examples of human translated data,
Okay.
or in some instances, maybe just spoken language, right? So some of the languages have started to develop a writing system only recently, and to develop systems for those, it's challenging.
So you mentioned English, Spanish, and French. Do you find those same parallels for things that don't use the traditional Latin alphabet that we see? Do you find that, I mean, obviously there's tons of translators for things like Chinese and Japanese, or even Russian, which uses a Cyrillic alphabet. Do you find that the same is kind of true there, where the languages that are broadly spoken generally follow the same pattern? Or do you find that there maybe are interesting challenges that Chinese or Japanese might present that things like English and French and Spanish don't?
I think it has less to do with the alphabet, or whether they use Cyrillic or Arabic or Chinese, or uh, characters or katakana. I think it has less to do with that, and it has more to do with how divergent the languages are in terms of the way they structure information, the way they pack information. So, uh, English, French, Spanish, they're pretty much the same language, just different characters, different words.
Sure.
All of them are subject, verb, object.
Yeah.
Yes, some of them have more morphology, but it's they're much closer than, let's say, when you look at English and Japanese, or English and Korean.
Right.
So that poses a little bit more challenges, because lots of the information in Japanese sentences is only implicit, for
Right.
example. So to figure out, or to build models that figure out that implicit information, or even more difficult when you translate into Japanese, to figure out how to represent, or to implicitly
Right.
to kind of to transfer the information. It's a little bit more challenging than just going from French to Spanish, or from French to English, or vice versa.
It's interesting you say that, because I would imagine you and folks that have backgrounds similar to yours, you look at languages like French, Spanish, even German, and English, and you say those are the same thing. But I will tell you that my 16-year-old daughter, who's taking Spanish, would completely disagree with you, and I think most people would. But I can see, when you look at it from a pattern matching perspective, from a machine learning perspective, it's much easier to identify those kinds of languages versus things that use different structures. I know Justin Jeffers, who's on my team, is pretty fluent in Japanese as well as English, and he tried to explain to me once just how the sentence structure works and how you have to think about rearranging the language entirely, and it is quite different. And so I don't think most people get an opportunity to look at languages the way that you're describing them. So that's awesome that you were able to bring that up. Thank you. All right, we're running short on time. We actually only have 6 minutes left, and I have a whole list of questions that I really wanted to get through with you here. So there's one thing I really want to touch on. I know we've talked a little bit about NLP and machine learning and things like that, but you've actually published a book on some of these topics. It's called The Theory and Practice of Discourse, Parsing, and Summarization. Can you tell me about your book? I'd love to know more about what that went into. I've written a book myself, but I want to know about yours.
Oh my goodness, you did do your research. Yeah, so that's a book that I published by elaborating a little bit more on my PhD thesis. So the the book is essentially built on a premise that a text is more than a collection of sentences. So the same way, let's say a sentence is more than a collection of words, right? And that's something that is very intuitive for all of us. To when you read documents, sometimes you say, this sentence is just a word salad, or this document. It is possible that sentences, well, every single sentence is good, but when you put them together, it can still be an incomprehensible document, right? And if you don't believe that, you can just take a text and shuffle the sentences, and it's a big mess, right? So the book was about how the book developed formalism that kind of explained what would make text, how that would formalize the underlying hidden structure of coherent texts. So
that sounds interesting.
The cool thing, if you manage to formalize it at that level, right, from a mathematical and from a computer science perspective, then you can do things like you can ask yourself algorithmic questions. You can say, how many interpretations, discourse interpretations, can I have for a particular text? And you can build whole tree structures, discourse structures for text, and you can understand text at a very different level that you understand them when you look at them just as a simple sequence of sentences. So, for example, you can say, this text actually has two main arguments and presents two big arguments in contrast. And this one, here's the core idea, and now here is something, a part of the text that elaborates on that idea, right? So think of that kind of recursively across the entire text. And then once you have that understanding, then you can do a bunch of stuff with it. You can for example, determine whether texts are well written or badly written from a discourse perspective, which is something that I collaborated with colleagues from educational testing services, and that got incorporated into software that does automated essay scoring and provides feedback to students who learn how to write. Or you can build a summarization system. So once you manage to really formalize it mathematically, and once you manage to have algorithms for that, you can also develop quite a bit of applications, quite a few applications. And that's what that book was about.
Very, very cool. All right, so we have 3 minutes left, and I want to wrap up with something at the end. So you've been at Amazon almost 4 years. What's one launch or improvement that you've worked on that you're the most proud of? Something that maybe improved customers' experience with Alexa or something like that.
Well, I think I got that question also when talking to other scientists that asked me, Daniel, what's the paper that you're most proud of? And every single time I thought about that, I realized that I'm not proud of anything. Or in put it differently, every single time I write a paper, or every single time we launch a product, I'm super excited. And I think that's the most amazing thing that has happened in the history of mankind.
That's good. That's a good feeling.
I feel like that for about a few days. And after a few days, I'm like, oh my God, but if I was just a tiny bit smarter, I could have presented, or I could have built a better paper.
Sure.
Or in the case of a service, if we were a little bit smarter, the service would have done something else. So in general, when I look back, I'm happy with the work that I've done, but I cannot point to anything as, oh, look, that paper is awesome, or that service is awesome.
Sure.
So I end up being a little bit embarrassed in some sense. Oh my goodness, look at that paper, how poor it is now when I look at it 20 years later, or look at the service. It can be improved in so many ways.
It sounds like you know exactly what it's like to be a software developer. I will finish my code today, and I will open it back up tomorrow, and I'll be like, who wrote all this garbage? This is terrible. I know exactly what you're describing, and I think a lot of the people that are watching have probably had a very similar feeling, where you're proud of it for a very brief, fleeting moment, and then it's gone. I can't tell you the number of times that I've gotten into code that I personally wrote only to say, why would someone do it this way? This doesn't make any sense to me. And it's only because we've grown, right? We've learned, we've taken the learnings that we had there and applied it to new things. I think that's outstanding. So I mentioned earlier the KDD 2020 conference that's happening. I know that you've got a few people from your organization that are participating in that this week, right?
Yeah, actually, there are quite a few people from all across Amazon. I'm also giving a talk today at KDB.
Oh, very good.
I'm one of the invited speakers there. So, but what I would encourage you or anyone else who's listening to this interview, there's quite a bit more about the Amazon participation in KDD on the Amazon Science website. So that's a website that has quite a bit of information about tons of issues or tons of problems specific to science at Amazon, and I encourage you to take a look at it.
It's a really hard URL to remember. It's amazon.science. So for all of you that are like,
Exactly.
I gotta Google that and find it, amazon.science will get you there. We've done some good jobs with our URLs, actually. If you're looking for an opportunity, amazon.jobs is the place you'd go. So amazon.science is the place you'll find all about what they're doing at KDD this week and a number of other science initiatives. That's where they really spend a lot of time focusing on what the interesting scientific approach and research that's happening at Amazon is going on. So that's fantastic. So Daniel, I can't thank you enough. We are right at time. I can't thank you enough for being here today. This has been fantastic.
Thank you very much, Jeff. It was a pleasure.
Certainly. So thank you guys all for tuning in. Just as a side note, we have another stream here on this channel in about 30 minutes. We're going to be talking about Alexa Conversations and how that works, and some of the people that put it together are actually going to be here joining me and Justin Jeffress. So please join us here in about a half an hour. But with that, Daniel, I'll say thank you so much again for being here. Thank you, everyone, for tuning in, and we will see you all again very soon. Bye-bye.
Thank you.